Hi and welcome to the lesson about joins. So joins, I would say that it's quite an innocent operation in batch processing because you generally have your rightmost data set, your left data set. You just want to join the corresponding records between them and generate a single row from that combination. In streaming processing, due to its time-based semantic, the same operation is much more difficult or much more challenging. It requires different components involved, and I think I will show you that just with this quick example. So here we have the processing time, which is our real time. It's 10 o'clock, and the event time for both streams is the same, so it's 9:45. And when you have to join two records from them, so boxes and squares, in circles, well, you can do it because they are perfectly aligned. The problem starts when you lose this alignment. So when one of your producers or consumers is slower than the others. And for example, here we have our first stream, which is at 10 o'clock. So 10 o'clock we push the box, the square, and yeah, there is nothing to join because the 10 o'clock on the bottom stream is just now, so 10 minutes later. And typically here is the same story. We lose the join. We cannot join these records because they are not anymore aligned in time. So how to deal with that? There is a good news. Since we are talking about stateful processing, you can solve this issue by leveraging the state. And let's see this in an example. So again, we have the the join which is unaligned, 10 o'clock for the square, and we store it in the state store for some time, typically for the GC watermark period. And here, when it comes to our late record, well, it's a little bit later, much more than 10 minutes from the previous example, when we know that in the state store there is something corresponding that it's waiting for that. And now we can do the join very easily just by leveraging the state store and this internal buffering. So it's a security buffer for a successful join, but it doesn't guarantee the successful join. It doesn't guarantee that every time you will be able to join your unaligned streams, because there is this GC watermark that can make you in a trouble. So here we have the event time at 10 o'clock, processing time 10 o'clock, it's perfectly on time. And the GC watermark at this moment is 9:50. So we get our record, we store it in the state store. That's completely normal. Later on, the time is moving on. We have new data in our pipeline. And of course, we change the GC watermark according to our rules. And this GC watermark removes the buffered state because generally it says us for any state that we are not expected to get any data prior that time. And so to not accumulate this state indefinitely, well, we remove it. And now when you have some data coming in for the join, like for example here, well, it's a bad luck. There is nothing you can join in. So yes, that's for probably, I think that's the best lesson I can give you and show why streaming processing is such a challenge regarding these simple operations like aggregations, like, I don't know, maybe count distinct, when you need really to either buffer a lot of things or buffer them for a long period of time in order to make a successful operation. Of course, if you are using the batch layer and your data is late regarding your processing time, or maybe your event time partition is not complete yet when you start your processing and you join data in batch, of course you will also miss this join, but generally it's not that frequent as for streaming processing with quite low GC watermarks. So thanks for watching and see you in the next lesson.